The last section we're going to look at from this chapter moves into right triangle trigonometry, which is a bit redundant to say because when we're talking about trigonometry, we almost exclusively talk about it in the context of right triangles, even though technically it's more broadly a discussion of triangles as a whole, where the first thing we want to do is set some basic notation here for our pieces, as there's some unique relationships that occur with right triangles, where we call the hypotenuse length C, and we call the lengths of the legs A and B. From this, we can then determine some more information in terms of some special functions that you should have heard of before, called sine, cosine, and tangent, where if we look at the sine function applied to the angle A, we will get that this is equal to the ratio of side lengths A and C, that is the length of the leg opposite over the length of the hypotenuse. Meanwhile, for cosine, if we look at cosine of A, we get that that measure is equal to the ratio of the adjacent leg B to the hypotenuse length C. And finally, the tangent function has the relationship opposite over adjacent, so that would be A over B. For those of you who've done this stuff before, it should be just about everyone in here. This is where you get those mnemonics like so, ka, to, a, for making sure that you remember those relationships: opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Where, to help us out, we're going to look at one quick example first. So let's say we have the right triangle given below, where we are given the leg lengths 5 and 12, and are asked to find sine, cosine, and tangent in terms of the angle A. So here, we're given that triangle, and mainly all we have to do here is just remember how sine, cosine, and tangent work here. So sine, remember, is the length of the side opposite over hypotenuse. So that's where you get the so, if you were. Which here, the side opposite, it has length 5, and the hypotenuse has length 13. So you get 5 over 13 for sine of A, regardless of what A is. We're just taking that as a general value here. Then for cosine, we have adjacent over hypotenuse, where the adjacent side length is 12 and the hypotenuse length is 13. And then finally for tangent, we have opposite over adjacent, or 5 over 12. Now let's look at one more example, where here what we want to do is find the length of the hypotenuse for a right triangle with side length adjacent 10 and angle that is adjacent to measuring 60 degrees. So what we need to do here is, again, remember that the cosine function is the one for adjacent angles. So we're going to use cosine, where we have cosine of 60 degrees is equal to 10, the adjacent, over the length of the hypotenuse, which is C. And then from here, we want to do a little bit of rearrangement, which would give us that C is equal to 10 over cosine of 60 degrees. And cosine of 60 degrees is, hopefully some of you may remember, if you can recall the unit circle, or if you can use this on your calculator, whatever you need. Either way, you should get the cosine of 60 is equal to 2. So C would be equal to 20.